Hi, it's me, Tim Dodd, the Everyday Astronaut. The great solar eclipse of 2017 happened across the entire United States, and it was the coolest thing ever. But what could possibly make an eclipse even cooler? Well, what if you were up in space? What would a solar eclipse look like from up there? Well, in case you don't know, space is really big, and there's many different points in space one could be. So, today, we're going to compare what we see here on Earth to what a solar eclipse looks like from different points in space. Let's get started.
3, 2, 1, 0, and liftoff.
This episode is brought to you by thegreatcoursesplus.com.
How loud is it gonna be?
Elliot, for the 1000th time, it's not going to be loud.
We're here in Beatrice, Nebraska for the great solar eclipse of 2017. Now, to have a total solar eclipse is actually a pretty rare thing, so to have one go across the entire continental United States is really exciting. So we figured we'd ask the question, what if instead of driving across the United States and to wind up at some field in the middle of Nebraska with a bunch of strangers, what if we were to board a spacecraft right now and to view a total solar eclipse from different points in space? Let's find out.
That is awesome!
So let's start off by what it would look like if you were just at the edge of space in a quick little suborbital hop. There are currently just two companies that will soon be offering suborbital space tourism flights. Blue Origin with their New Shepard and Virgin Galactic with their Spaceship 2. Now both companies will offer anyone who has the cash, and a lot of it, the chance to kiss the edge of space and fall back to Earth, leaving those inside with around 4 minutes of weightlessness and a once-in-a-lifetime experience. So what would a solar eclipse look like from up here? Well, looking up at the moon and the sun, it would look almost the exact same as it does down here on Earth. Why is that? Well, these suborbital flights only go up about 60 miles or 100 kilometers in altitude. Now compare that to the 228,000 miles or 360,000 kilometers away the moon is, and we'd only close that gap by about 0.03%, meaning the moon would end up looking an indistinguishable amount bigger. We would, however, be above the Earth's atmosphere, so your view of the eclipse would be crystal clear, free of distortions and clarity issues or clouds in our own atmosphere. But perhaps the coolest thing would be at 60 miles in altitude, you could look below you and see the Earth go into the full shadow of the moon. Now, part of me wonders, if you paid hundreds of thousands of dollars to experience the magic of spaceflight, get the overview effect, and see the curve of the Earth, would an eclipse just end up being a distraction? Maybe you'd be better off witnessing it here on the ground instead of taking away from your 4 minutes of spaceflight. But who knows? Maybe someone someday will be able to compare those two for us. Maybe that someone will be me. Time to sell the house. Next, what if you were in low Earth orbit, say on board the International Space Station or some other spacecraft? Well, we actually know what this would look like because it's happened a handful of times, including the 2017 eclipse. The first people to ever view a solar eclipse from space was the crew of Gemini 12. On November 12, 1966, Jim Lovell and Buzz Aldrin flew their Gemini spacecraft directly through the center of the shadow of the moon. At 6:52 a.m., Lovell reported to Mission Control, well, we hit the eclipse right on the money. After Gemini 12, there would only be 3 more times when astronauts or cosmonauts would experience an eclipse from low Earth orbit. Until this year, when the crew currently on board the International Space Station got a chance to see the eclipse 3 times. Unfortunately, the ISS never quite passed through totality, but they still managed to get these incredible images. So, being in low Earth orbit is an interesting place to be. When in low Earth orbit, you're just 250 miles or 400 kilometers above the surface of the Earth. So again, it's not like you're going to be that much closer to the moon and therefore have that much more of the moon block out the sun. But an interesting aspect of seeing an eclipse from low Earth orbit is how much time you'd spend in the shadows. Since the objects in low Earth orbit are traveling at 17,500 miles an hour or 28,000 kilometers an hour, astronauts can only get up to around 20 minutes between the start of an eclipse and the end of an eclipse, which is much less time compared to here on Earth where an eclipse can last 3 hours. Since the International Space Station orbits the Earth every 90 minutes, the crew on board gets a chance to see multiple eclipses, like in 2017 when they were able to see 3 partial eclipses. Alright, next up, what would a solar eclipse look like from geostationary orbit? Satellites in geostationary orbits are very common and their orbital period is exactly 24 hours. This means they look like a fixed point in the sky. Think of how GPS satellites are constantly in the same place in the sky, or television and communication satellites. Now, despite this being a very common place for satellites, no astronaut has ever been in a geostationary orbit. At 22,000 miles or 35,000 kilometers in altitude, we're 1/10 of the distance to the moon. This means the moon would appear about 10% bigger, which would make for a little bit longer time spent in totality. Which is cool, I guess, but it might end up blocking some of that beautiful corona we all drool over. From here, the real treat would be your view of the Earth. At 22,000 miles in altitude, you'd be able to see the entire Earth out the window of your spacecraft. You'd be able to watch the shadow of the moon transit the Earth in its entirety. Here's what that would look like. Notice this is sped up a lot. In real life, you'd be able to watch the moon's shadow crawl across the Earth for several hours, which would probably be really cool. So now we get to the question of, what if you were out there in lunar orbit? I mean, technically the moon would eclipse the sun every time you were in the shadow of the moon. Buzz Aldrin realized this in a tweet on August 19th, 2017, stating, "It occurred to me that I gotta see quite a few solar eclipses every time we orbited into the shadow of the moon." Those onboard Apollo spacecrafts would orbit the moon approximately every 120 minutes, so they technically experienced an hour-long solar eclipse every 2 hours. Pretty cool, but also sort of cheap, and certainly wouldn't have the same magic as when the moon and the sun are approximately the same size in the sky. I think that's half of what makes a total solar eclipse here on Earth so special, is that the moon just perfectly blocks out the sun. So now the ultimate question, what would a solar eclipse look like if you were standing on the moon? Well, this is kind of a funny one when you think about it. During a solar eclipse, the portion of the moon facing the Earth is entirely in the shadow. You'd be right in the middle of a new moon since the sun is directly behind the moon. In other words, you'd be smack in the middle of a lunar night, which is not where you'd ever want to find yourself. At minus 243 degrees Fahrenheit or minus 153 degrees Celsius, I think I preferred my summer day in Nebraska, thank you very much. But from the surface of the moon, you'd see the Earth about 4 times bigger in the sky than we see the moon from Earth. So the Earth would still be relatively small from the moon, or as astronaut Jim Lovell stated after flying around the moon on Apollo 8, you look back at Earth from the moon and you can put your thumb up to the window and hide the Earth behind your thumb. Everything you've ever known is behind your thumb. And that blue and white ball is orbiting a rather normal star, tucked away on the outer edge of a galaxy. You realize how insignificant we really all are. Everything you've ever known, all those arguments and wars, is right behind your thumb. So with the Earth that small in the sky, you just might miss the moon's shadow moving across the Earth if you weren't paying attention. Not only that, but you don't even get to see the sun for another 7 days or so. So really, would a solar eclipse on Earth even be considered a solar eclipse on the moon? When the Earth passes between the moon and the sun, we call it a lunar eclipse on Earth since the Earth casts its shadow over the moon. So if you were on the moon and you were in between the sun and the Earth, wouldn't it be considered an Earth eclipse, an earthular eclipse, a terrene eclipse? So really, a full solar eclipse on the moon wouldn't be when the sun is blocked by the moon, but instead when the sun is blocked by Earth. What would this look like? Well, since the Earth is 4 times bigger than the moon, the sun would be completely blocked out for much longer, up to 107 minutes. With the Earth in front of the sun, the atmosphere scatters light from every edge, making it so you'd essentially be seeing every sunset on Earth at once. Whoa. Although no human has been on the moon during a solar eclipse, the crew of Apollo 12 did get to see the Earth eclipse the sun as they returned to Earth from the moon. The event happened when they were only 27,000 miles or 43,000 kilometers away from the Earth. Alan Bean recalls this spectacular moment. The atmosphere is illuminated completely around the Earth. Pete Conrad added, "It has blues and pinks in it, but instead of being banded, it's segmented. I don't know why." Now that sounds like an extraordinary eclipse that you could only witness from space. So there we have it. Long story short, of course I think it'd be pretty cool to see an eclipse from space, but would it actually be cooler than right here on Earth? I don't know. Something I learned witnessing this year's eclipse was so much of the energy comes from celebrating something bigger than all of us together. Humans from all walks of life coming together and screaming at the sky out of sheer uncontrolled excitement. To me, that's pretty darn special. And for once in my life, I don't think the answer is rockets and spaceships. What do you think? Do you think it'd be better to see a solar eclipse from space or just right here on Earth? Let me know your thoughts in the comments below. And while you're at it, make sure you subscribe so you know when new videos come out. A big, huge thank you to my Patreon supporters for helping make this and other Everyday Astronaut content possible. All your support has been super encouraging. If you want to help contribute, please visit patreon.com/everydayastronaut. Thank you. Don't forget to check out my web store for shirts, hats, prints, mugs, and lots of other fun stuff at everydayastronaut.com/shop. As always, all the music in my videos is original. Feel free to check it out and download it for free at soundcloud.com/everydayastronaut. Show it to a friend. This episode is brought to you by the Great Courses Plus. The Great Courses Plus is a subscription on-demand video learning service that lets you learn from some of the best professors and experts from around the world. With over 7,000 video lectures, you can learn about even the most complicated topics, like, say, rocket science. That's exactly what I'm currently doing. I'm watching The Fundamentals of Flight by Professor James W. Gregory. It's giving me some really good insight on why so many of my space planes in Kerbal Space Program don't quite work out that well. The Great Courses Plus is offering a free 1-month trial with plans starting as low as $14.99 per month. Please visit thegreatcoursesplus.com/everydayastronaut. Click on the link below to start your free trial today. Thanks everybody, that does it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people.